matrix. Determinants are associated with only square matrices. Determinants are associated with only square matrices. Square matrices. I'll write it on the board, so don't worry. Determinants are associated with only square matrices. That means we can only be asked to find the determinant of what? Square matrices. So that one I wrote long like that, we can't find the determinant of it. That's the meaning. So a square matrix is a matrix in which the number of rows equals what? The number of columns. Are you all here? So let's write. A square matrix. A square matrix is a matrix in which the number of rows is equal to the number of columns. Full stop. Thus, and are both square matrices. Full stop. Full stop. So we are saying that this matrix, this is a 2 by 2 matrix. Can you see? The number of rows are how many? 2. The number of columns are what? 2. This one 2. How many rows? 3 rows, 3 columns. So this is 2 by 2 matrix. That's why it is square. This is 3 by what? 3 matrix. That is why it is what? Square matrix. Are you all here? Yes. Any other question? No question. From China. So anybody wants to come close to buy? Of determinants. Properties of determinants. Properties of determinants. We have 3 basic properties we are going to look at before we start solving questions on determinants. So that's point. That's right. 1. Properties of determinants. There are just 3. Then when the entire elements of any row or column are 0, throughout.
Determinant
is 0. Full stop. The determinant is 0. Full stop. If the entire elements
of any row or column
are zeros throughout, the determinant is 0. This is what we mean. So when you have an entire row, this is a row. This first row, is that not it? This second row. So the second row are zeros, entirely 0 throughout.
So once they are entirely 0 throughout, when you find the determinant, it will be 0. That's the rule. Or this rule, you can also have
column. You can also have 0, 0 like this.
So if
the entire row is zeros,
then the determinant is what?
0. If the entire column is 0, 0, the determinant is also 0. That's the meaning.
Connected.
Two columns. Has
Equal.
or you say the determinant is 0. What did I say?
When any two rows or any two columns
Has equal or the same element. Equal element.
or the same element. Are you all here? Equal
Or the same element. The determinant is 0.
the determinant are the same. Maybe AA.
BC. What do we say? Any two. Can you see?
So this row, they are the same. Can you see?
This row are the same. This row are also what? The same.
So the determinant of such, sorry, so what's the determinant? So the determinant of this
Is 0. That's the meaning. So the rows are the same.
any two rows. So or
It's still 0.
you can also have 3 by 3.
You can also have 3 by 3. A.
B, C,
D. E. So this
determinant is 0.
are you out here? So anytime
There is any two rows.
the number, the elements are the same.
The entries are the same throughout. The entries are the same. So this row,
And this row. So this one row, this another row. So any two.
if the entries are the same in that row, it is 0.
Or if the entries in columns
If the entries in column any two entries in a column
are the same, then the determinant is also 0. So you see, two rows
have equal entries. Two columns have
equal entries. One doesn't have, it doesn't matter. So the determinant will be 0. The third property. The third property says that when any two rows or any two columns
are interchanged,
three. Are you ready? Three. When any two rows or any two columns are what? Interchanged, then the determinant of the new matrix. Then the determinant of the new matrix is the negative of the first, the negative of the original matrix. The negative of what? The original matrix. Are you all here? The negative of the original matrix. The determinant of what? The new matrix is what? Is the negative of the original matrix. Very good. Negative of the original matrix. So let's see what we mean by that. So if we write out a 2x2 matrix, they say if this one is A, B, C, D. Can you see? If this matrix is A, B, C, D. Okay, if this matrix A, B, C, D. And then we interchange. Sometimes we interchange. We say what? When any two rows or two columns are what? Interchanged. So let's interchange two rows and two columns. When we interchange, what do you get? Let's interchange rows first. C, D, A, B. Is that not it? Can you see? Interchange. Send this one up, bring this one down. Do you understand? That's the meaning of what? Interchange. So we have interchanged rows. Now let's interchange columns. If we interchange columns, what do we get? B, D, A, C. Do you understand what we are doing? This is the original matrix. Is that not it? Original matrix. Then we have interchanged rows here. The first row, guys, AB is now down. Can you see? CD is now up. So we brought this and send this. But here, we brought first column to right and send this one this way. That's what we have done. Can you all see? So we brought this one here and send this one there. Can you see? So when you find the determinant of this 2, so what? So we are saying that the determinant of this one we have interchanged. The determinant of this one we have interchanged is going to be equal to the negative, are you watching? Of the determinant of the original. You all see. That's the meaning. Determinant of the original. A, B, C, D. The same way, when you find the determinant of the other one, we have interchanged. B, A, D, C is also going to be equal to the negative of the original. Are you all here? The original. A, B, C, D. That's the meaning. We can also have 3 by 3. So we have 3 by 3. 3 by 3. A. We can use numbers, but I just want us to be variables. A, B, C, D, E, F, G, H, I. Are you all here? This is original. So this is original matrix. Can you see? So let's interchange these two rows and leave this one. Can you see? So when we change, interchange, we get G, H, I, A, B, C. We've done nothing to the second row. Can you all see? We've done nothing to this row. So this one is equal to the negative of the original. A, B, C. E, H, I. That's the rule. You understand? So if you also interchange the column, you still get the same results as the negative of the original. So we can interchange two columns in this case, maybe this and this or this and that, anyone. So bring C, F, I here, maintain B, E, H, and send this one here. A, D, G is equal to the negative of the original. And our original is A, B, C, D, E, F, G, H, I. G, H, I. Any question? Any question? So copy quickly. Once they ask you to find the determinant of a similar matrix, and you observe that something has just been swapped. Can you see? Something has just been interchanged, so you don't need to waste time to solve it again. So just negate the answer you already found for what? The original. Are you all here? That's the meaning. So sometimes in the exam I can put questions like that together, and you may not even realize that I interchange certain things in the second matrix to get the second matrix. I interchange certain things in the first matrix to get the second matrix. So I can do that in the exam for you, and then you may not realize it. So they just apply the rule. You don't need to solve this again. Waste of time. Just attach negative to it. That's all. Any other question? So let's an example for 2 by 2, and then another example for 2 by 3. Finding determinants of 2 by 2 matrices. Of 2 by 2. Finding determinants of 2 by 2 matrices. 2 by 2 matrices. Romanus. Is it the son of Mr. Ibu? Finding the determinant of 2 by 2 matrices. In finding the determinant of 2 by 2 matrices, in finding the determinant of 2x2 matrices, comma, we multiply the principal, diagonal, and subtract the product of the secondary diagonal entries from it. In finding the determinant of 2x2 matrices, comma, we multiply the principal diagonal entries. Principal diagonal entries is top left to what? Down right. Are you all here? I'll illustrate it. The secondary is top right to left, down left. We'll illustrate it. Are you all here? Yes. So this is what we are talking about. Those if A is equal to A, B, C, D, then determinant of A. We said, everybody watch, S up, S up, S up, everybody. So we said that you multiply the what? Principal diagonal. And principal diagonal is, my friend, start writing. Principal diagonal is top left to where? Down right. Can you all see? Bottom right. So multiply them. What do you get? A, D. You see? They multiply the secondary diagonal. Top right, bottom left. Can you see? B, C. After that, subtract it. Can you see? That's what we meant by that. So multiply this way, multiply this way, and find their difference. Can you all see? Yes. Any question? So e.g., all right, e.g., if A is 1, 2, 4, 5. Find determinant of A. So let's find determinant of A together before you write. Determinant of A, 1, 2, 4, 5. Can you all see? So we say multiply this. Multiply this. Can you see? What do we get? 1 times 5. Are you all here? Minus, is that not it? Multiply this by that. Can you see? 2 times what? 4. But multiply 1 by 5, what do we get? 5. But multiply 2 by 4, what do we get? 8. When we subtract, what do we get? Negative 3. Any question? Negative 3. How did I work? Doreen. Which of them is Doreen? Doreen. What of you? Go in the glasses. Ellen or Helen? Ellen. Doreen. And you? Doris. Hey, Morris, Doris. That is, someone should give us 2x2 matrix. 6, 7, 20, 10. Okay. Find determinant of B. So pens down, everybody. Huh? Is it? Which continue? Okay. So let's do that together. 6, 7, 20, 10. So we said you multiply principal diagonal. 6 times what? 10. Minus. Multiply this. 7 times what? 20. 6 times 10 is what? 7 times 20 is what? 140. That's sure. Okay. What is subtract? What do you get? Negative 80. Negative 80. Any problem? Are you confused? The way you are watching? Yeah, okay. So I want to see how I write the English for you to understand. Okay, so it is like this. Three by three matrices. In finding the determinant of 3 by 3 matrices, we use the sign convention rule. The sign convention rule of 3 by 3 matrices: the first entry, put a plus there. The second, on the first row, put a minus there. So you have plus, minus, plus. Minus, plus, minus, plus, minus, plus. So the sign convention rule is just about making sure that no particular sign is repeated after this preceding one. Are you here? So if it's plus here, the next will what? Minus. The next will plus. The next will minus. The next will plus. The next will minus. The next will plus. Minus, plus, in that order. Are you all here? That's the meaning of the sign convention rule. So we said we are going to apply this together with any rule. So you know the sign convention rule. So you choose any rule you want to use to find the determinant. Somebody can choose, Doreen can choose the first rule. Mike can choose what? The third rule. You all get the same answers. Are you all here? Then Morris can choose the second column. You also get the same answer. So in the exam, don't be canceling your work because somebody choosing a different thing. You can use different rule, different column, also get what? The same answer. Just know this and pick any rule or any column and work with it. You'll be okay to go. Are you all here? Yes. So we are saying that we find the determinant of 3 by 3 matrices by deleting the row and the column containing the entry. We are going to illustrate all that of the chosen row or column. After which we multiply the deleted entry by the determinant of the resulting 2 by 2. So when we delete what we are coming to use, we'll be left with a 2 by 2. I'll illustrate all of them in this example. Now let's watch. This is what we are saying. Our matrix A is 2, 4, 5, 1, negative 2, 7, 8, 3, 4. Now we know our sign convention rule. Right there. You know the sign convention rule. If you want, we can write it somewhere, but it is here also. It is here already. So we can choose which row. What should we choose? We should choose which row. Choose. What should we use? Row or column? Row what? Row 1. Choose row 1. Are you on here? Choose row 1. Can you see? Don't write, please. Watch. This one is a little complicated. Choose row 1. So let's see how we find the determinant of this matrix by choosing row 1. We know the sign convention rule, so leave it there. Then we are choosing row 1. So where is row 1? This is row 1. Can you see? This is row 1. So we said delete. So we are coming to delete what? We are coming to use the first value of row 1. Are you watching? Row 1 has how many values? 3 values. 2, 4, and what? 5. Want to work with the first value. So, if you are working with the first value, let's count. Determinant of A, 2, 4, 5, 1, -2, 7, 8, 3, 4. So we are using row 1. We are working with 2. So we said delete the row 1 is what? 2, 4, 5. We want to deal with the first one. Delete the row. I want to delete the row that contains number 2. We have deleted it. Can you all see? Delete the column that contains 2. I want it. When you do that, you'll be left with what? The resulting. You see? The resulting what? 2 by 2. You'll be left with 2 by 2 matrix. What? When we delete this one and delete this, that means it's left with 2 by 2 matrix. Can you all see? It's left with 2 by 2 matrix. Can you see? So you're going to find the determinant of the resulting 2 by 2 matrix. This is the resulting 2 by 2 matrix. Are you all here? So you are going to find the determinant of it. So write it like this. What are the values? -2, 7, 3, 4. Any question? You go over. Very good. So first, you have to know your sign convention rule. Plus minus, that's one in your head, or you write it on your question paper. Then you ask yourself, which row or column am I going to work with? You said we should work with what? Row 1. So we have chosen row 1. So choose row 1, and our row 1 is 2, 4, 5. So you can write it like this. Pick the first one in that row. Are you ready? Write the matrix down on your question paper or in your answer booklet. You know you can do rough work there. So write the matrix down in your answer booklet as your rough work. Then delete that row of the 2. The row that contains the 2. We have deleted it. Can you see? The column up to down is column. Is that not it? So delete that 1, 2. Through 2 like this when you delete. Some numbers will be there that are not deleted. Can you see those numbers? Yes. They will follow each other. So write it down like we have written. -2, 7. -2, 7. Can you see? 3, 4. 3, 4. That's the meaning. Can you see? Yes. Then you come to your sign convention. What is our sign convention? Can you all see? This is our sign convention. We are taking what? Row 1. What is the row 1 of this sign convention? Is it not this one? Can you all see? Row 1. Is it not this sign? This one? Yes. So which one do we pick? We pick the first one. There are 3. 1, 2, 3. Can you see? Here too. How many are there? 1, 2, 3. Are you watching? So we are picking the first one. The first one is what? Plus. Plus. Is that not it? Yes. So you come and put a what? Plus here. I want to do the simple illustration. But you know that anything that is plus, you can decide not to put it there. Is it not true? Yes. So you can decide not to put it there. Because it won't have any effect on the result. Is it not true? Yes. But because we explained the sign convention rule, so let's put it there for the first time. Are you okay? So the sign convention rule says the first entry of that row you have chosen, put a plus there. Are you all here? Yes. So we have finished deleting first row, first column. Now we want to now delete the other. We are not coming to work with this one. Can you all see? So in your question paper, you can rewrite the matrix out on your answer book. Rewrite the matrix out again. 2, 4, 5, 1, 2, 7, 8, 3, 4. We are with what? We are now at the second entry. Can you all see? The second entry is what? 4. So delete the row that contains 4. We have deleted it. Delete what? The column that contains 4. Are you all watching? When we deleted this one, we multiplied 2 by the remaining. So what are we going to multiply by? The one we are dealing with, 4. We are going to multiply 4 by. Can you see the other 2 by 2 matrices left? The one we didn't cancel. Can you see them clear, everybody? So mention them for me. 1, 7, 8, 4. Are you watching? You finish this. Now you are going to pick something from the sign convention rule. Are you here? We are finished picking this one. We are going to pick the second rule. So the second value is what? Minus. Are you here? Minus. So that means come and put what here? Minus. You see? Don't write. If you are writing, you understand. Gentlemen, start writing. So sign convention says minus. So I finished the second. I want to do the third. Are you all here? I want to do the third. So you can rewrite your matrix somewhere in your answer book so that you don't make mistakes. So you have what? 2, 4, 5, 1, make 2, 7, 8, 3, 4. So we are now dealing with what? 5. So look for 5 in the matrix. Is it not here? So delete a row. Go and cancel it. Is that not the row? Is that the column? Yes. So you cancel here, you cancel it. How many? Which ones are left? Somebody should tell us. 1, negative 2, 8, 3. Very good. Can you see? There you come. 1, 2, 3. The number is the third. So go to the sign rule and look for the third one. The third is what? Plus. So there should be a plus here. Is it not true? Yes. Can you see? Then you continue. Watch, everybody. You see? So now, you see, we have now illustrated already how to find determinant of what? 2 by 2 matrix. Is it not true? Yes. So you now have to find the determinant of this. After I multiply by what? This. Find the determinant of this. After I multiply by what? This. Find the determinant of what? This. After I multiply by what? That. That's the thing. Are you all here? So you write it down or I should clear here. The determinant. What do we do? This way, is that not it? And this way. So somebody should tell me negative 2 times what? 4 minus 7 times what? 3. Is that not it? That's the meaning. Minus. We have decided to ignore this because it doesn't have an effect. Are you okay? So don't worry. So minus 4. And the determinant of this is not like this and this. So we have 1 times 4 minus 7 times 8. It's a plus here. Plus 5 into bracket. Now it is like this. Can you see? 1 times 3 minus negative 2 times what? 8. Don't want you to forget of the negative or you get wrong answer. That's why I put it in bracket. So let's go on. 2 into bracket. This times that. Negative 8. This times that. Can you see? I want us to do step by step. Yeah, because this is our first example. This times that. 4. 7 times 8 is what? 5, 6. Plus 5 into bracket 3. This one give us minus and another minus. Becomes what? Plus. Can you all see? 2 times 8, 16. So 2 into bracket. Let's do the simplification further. What do we get here? Is it 29? Negative. Okay. Here, what do we get? Negative what? 52, Okay. Watch. If I get the wrong answer, tell me. 5 into bracket, what do we get? 19. So do the multiplication for us. Here, what do we get? 58. Here, negative becomes what? Can you see? Positive what? 208, like this. Okay. Plus what? 95. And what is our final answer? 1, 2, 2, 4, 5. That's right.
Yes, sir.
Okay. Now copy. Any question?